Hi, everyone. Welcome to Math 60 at PCC in fall 2025. This is one of our first videos, and I'm going to take a little bit of time in this video just to talk about keeping track of your work mathematically. So this is what the format of the videos are going to look like. I'll have my pad of paper here where I write down notes. I will also post these notes that I write on paper later, so you'll be able to follow along in the video or review the notes. So this is Math 60. This is section 1.1, the preview, and keeping track of mathematical work. So this is a skill that you'll be building and developing throughout the math classes you take here and elsewhere. I want to give you the first look at keeping track of your mathematical work. People keep track of their ideas in a lot of different ways. I myself can be kind of disorganized. I'll often have a paper with some ideas here and here and here, and they all just kind of link around. But when you're sharing your work with somebody else, it helps to organize it in a way that makes sense for them. And keep in mind your future self is also another person. So your mathematical work should be interpretable by you in the future as well. So there are basically three types of mathematical work that we'll be doing on paper that just involve equations. And those are solving equations, evaluating expressions, and checking solutions. So when you're solving equations, you might have something like solve the equation 10x plus 7 equals 13x minus 23. When solving equations, you generally want to keep the equal sign right in the center as you work your way down and adjust the left and the right sides. So to solve the equation, 10x plus 7 equals 13x minus 23, you want to find the x that makes both sides equal. Oh. So if I have 10x plus 7 equals 13x minus 23, and I'm trying to find the x that makes both sides equal, it might help if I get all the x's on one side and all of the other numbers on the other side. So I could subtract 13x from both sides, keeping the variables with an x one on top of another. And then you do that arithmetic, 10x minus 13x would give me negative 3x's. I still have this plus 7 because nothing happened to it. 13x minus 13x is 0x, so that goes away completely. And I still have that minus 23 because nothing happened to that minus 23. And I kind of bring it into the left just to take up that empty space. Notice I've kept my equations on both sides and my equal sign is going straight down. The next step is to get all the numbers that don't have an x to this side, so I can subtract 7 from both sides. I keep track of it this way, and that gives me minus 3x equals plus 7 minus 7 is 0, so that goes away. So I have minus 3x equals, and I have minus 23, and minus 7 gives me negative 30. So I know minus 3 times my number is negative 30. If I want to find my number out, I can divide both sides by -3. The -3 and the -3 cancel just to give me an x, and the -30 divided by -3 gives me +10. And so there's my solution. X equals 10 will make my original equation, the left side, equal the right side. And I just keep track of it with these vertical equal signs. That's how you organize your work when you are solving equations. The next sort of mathematical operations we might do are evaluating. So we might want to evaluate, let's see. And I understand some of the operations that we're going to be doing, you may have not seen yet. Well, we will be studying them later. This is really just to show you how to organize your mathematical work. So evaluate 2x squared minus 10x plus 19 for x equals 5. And what that means is you take x equals 5 and you put 5 in every time you see an x. So we have 2x squared minus 10x plus 19 we plug in 5, and so we have 2 times 5 squared minus 10 times 5 plus 19. And now I'm going to simplify the right side. And when I do that, I'm just going to leave the left side blank. This left side is just going to be empty spaces because I'm not doing anything to this side anymore, and I'm just working on the right side. So 2 times 5 squared, which is 2 times 25. 10 times 5 is 50, and then plus 19. And I bring another equal sign down. 2 times 25, well, that's 50. 10 times 5, that's also 50, plus 19. The 50 minus 50 cancel, leaving me with just 19. So now I've evaluated, I found the value of this expression when x equals 5. It is equal to 19. And this is for evaluation. It's also for simplifying. So if you're ever asked to just simplify an expression, you start it on the left side with an equals, you work your way down, leaving the left side blank. And the last one is checking our work. So we're checking a solution. So for example, check that x equals 10 is the solution to 10x plus 7 equals 13x minus 23. This is actually what we did in the first example. We solved this and found that x equals 10 solves it. So now we're just going to check. So the mathematical notation we'll use for this is something like write your first expression on the left and your next one on the right. Make yourself a little table and then work your way down. So when x equals 10, we have 10 times 10 plus 7 and 13 times 10 minus 23. 10 times 10 is 100. 13 times 10 is 130. And then 100 plus 7 is 107. And 130 minus 23, that's also 107. Both sides are equal, therefore x equals 10 is the solution to this expression. So quick recap, keeping track of our mathematical work when we solve equations. Work your way down with the equal sign in the middle when we're evaluating or simplifying expressions. Let me add that. simplifying expressions. Then we start on the left and do all our work on the right with the equal sign vertical again. And when we're checking solutions, we set it up in kind of a table and work each side down until we see that they are equal, or maybe that they aren't equal. That's the end of this short video. The next video will be getting into section 1.1 a little bit more.